Hi folks, we're going to take a look at a second example of solving a system of linear equations algebraically. Okay, now one difference here is that when I look at the variables, there isn't one that's particularly easy to isolate like we saw in the previous example where one of the x's had a 1 as a coefficient. Here all of these have coefficients, so there's nothing that's obvious. So I'm going to have to pick one. Okay, so first of all let me label these equations, equation 1, equation 2. Okay, I'm going to choose equation 2 here because I've got this 0 on the right hand side, so at least I don't have to worry about that extra number hanging around. So here I've got to decide whether I'm going to isolate the x or the y. So since I isolated x last time, let me isolate the y. Okay, so from equation 2, okay, I'll leave the 5y on the left hand side, so bring the 6x to the other side. I got negative 6x, and so y is equal to negative 6 over 5x. Okay, so now I've isolated one of the variables. So again, it's nice that I don't have that extra constant hanging around. Okay, so step 2 now is to look for y in the other equation and replace it by negative 6 over 5x. Okay, so from equation 1, I've got 3x minus 10 times, well, wherever I see y, I can now substitute that with negative 6 over 5x. Okay, and then here equals 5. And now, as before, I have an equation that has only one unknown, so now I can solve this. Okay, so step 1 is to simplify. Okay, so here I'm multiplying a negative times a negative, so that means that's going to give me an addition. Okay, and here I'm multiplying 10 times 6 over 5. So remember that's like 10 over 1 times 6 over 5. So I can simplify the 10 and the 5, which is just equal to 2 over 1. Okay, so we're left with 2 times 6 is 12. 1 times 1 is 1. X equals 5. Okay, so here let's take a look. We've got 3x plus 12x, that's 15x. Equals 5, so x is equal to 5 divided by 15, which of course we're going to simplify that to 1/3. Okay, so we have the x value is equal to 1/3. Okay, and now the last step is to substitute this back into one of the equations to solve for y. Okay, now I notice here, back from step 1, I already had y isolated in terms of x, so this is the easiest equation to use. Okay, so here I'll take that, y equals negative 6 over 5, and wherever I see x, I can now replace that by 1/3. Okay, and so here y is equal to, well again, the 6 in the numerator will reduce with the 3 in the denominator, so that becomes 2 over 1. So we're left with negative 2 times 1 is 2, 5 times 1 is 5. And there we go. There's our answer for the y value. Okay, so let's just recap. So the idea here is to look for a variable that can be simplified. So here there was no obvious one to choose because none of them had coefficient of 1 or negative 1, so I tried to pick one that seemed easier in this case here because I had 0 on one side of the equation. Okay, so isolate one variable, substitute that into the other equation, solve. Once you find the value for one variable, substitute back to determine the value for the second. Okay, that's it for this one.